Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the series of linear equations, and we are in lecture number 8. In previous lecture we have discussed how to plot the line equation of line on the xy plane. In this lecture we are going to discuss pair of lines, how to draw pair of line, of course the way we draw line, pair of lines on the graph and what are the relationship possible. So let's come to the blackboard and understand. Two variable linear equation. Now in general, even if you think in general, if you draw two lines, either they will intersect or they will not intersect. When they intersect, for example here you got this x-axis and y-axis. The equation number 1 I have taken as a1x plus b1y equal to c1, where a1 is the coefficient of x. Coefficient, do you remember coefficient? Coefficient is a number which is with variable. Yeah, we have studied in basics of algebra. b1y, b1 is the coefficient of y here. Similarly, the second equation I have taken a2x plus b2y equal to c2. Now this is the diagram which is showing that these two lines are intersecting. Now two lines will intersect at one point, right, at a point. This point coordinate, let's say if the coordinates are, assume the coordinates are p comma q. How do we represent the coordinate? X, the first point represent, the first value represent x and the second value represent y. So suppose if this intersection point is p comma q, then p and q, this coordinate, this value of p, this value of x and the value of y, these values will satisfy both the equation, because both equations are crossing from this point. This point is on both lines. I hope I am clear here. Well, so this condition will be called, the pair of linear equations is said to be consistent, okay, if they intersect at one point. The second relation between two lines could be parallel lines. Parallel, as the name says, parallel means two lines which never intersect. Parallel which never intersect. So if they never intersect, they are parallel. In that case, in this situation, the pair of linear equations said to be inconsistent. So I have some questions for you, and there we will use graph to understand whether they are consistent or inconsistent. Okay, we can solve the linear equation, these kind of linear equation, by using elimination method also, but objective of this lecture is to draw on line. Yes, so by drawing this, by plotting these lines on graph, we will learn something which will be utilized for shortcut also to solve questions of exams. So let's get started. Question number 1. Question number 1, here you have the first equation is x plus 3y equal to 6, 2x minus 3y equal to 12. Now tell me one thing, are you having pen and paper with you? If not, then pick it up. I have told you earlier also, when you watch my videos, make sure that you are making your own notes. Yeah, so these 2 points, it's important to make note here. Make note of these 2 special points. You can draw the condition also. Parallel and intersecting. Intersecting is called consistent, and if the lines are parallel, the system is what? Inconsistent. Now we need to draw the line on this graph and understand whether they are inconsistent or not. So now if you have watched my previous lecture, lecture number 7 of linear equations, there I have shown you how to draw the line. To draw the line you need 2 points. Yes, to draw the line which follow a specific path, you need 2 points, minimum 2 points. You join those 2 points and extend at both sides, you get line. So let me have this equation number 1 here, which is what? x plus 3y equal to 6. Yeah, what do we do? What do we do? We take, you remember this box, yeah, x and y. Now I have told you my way of doing it. I keep it simple. Substitute x is equal to 0. See what you get, the value of y. If you substitute x is equal to 0 here, you will have 3y equal to 6. That way you will get y equal to what? 2. Yeah. I hope I can skip those steps, basic steps. We have solved so many equations in previous lectures, so I hope you are comfortable now. Then what I do, I assume I take or I substitute y equal to 0. If I take y equal to 0, what will be x in this case? Tell me what will be x in this case? Y is equal to 0. This term will become 0. So this term will become 0. So x will be equal to how much? 6. So you got 2 points for first equation. Are you okay with this? Are you okay with this? If not, then I'm sure you must have skipped some part of my previous lectures. Otherwise this will be comfortable. You must be comfortable here. Now next equation is 2x. Okay, shall we draw this first? Shall we draw this first on the graph? Fine, let's do it. Let me use blue color here or green color because we solved with the green color. Okay, so the first point is 0 comma 2. The first coordinate will be what? 0 comma 2. Value of x comma value of y. Here 0, x is 0, y is 2, here y is 2. So this is the first point, yeah, 0 comma 2. The second point is y is 0 and x is 6. Y is 0 and on x axis we have 6 here, 6. Okay, now let's join these 2 points and draw a line. Yes. Yeah, let me extend the other side also. Perfect. Okay, this is the first line. Okay, let me make it little thicker. Good. Okay, this is your first line. Are you okay with this? Yeah, a line which has come from equation number 1. Now look at the second one. Let me use blue pen here, blue color. So I have 2x minus 3y equal to 12. So again take x and y here. And if you substitute x is equal to 0, tell me if x is equal to 0 here, this term will become 0. So you have minus 3y, take with sign, consider the term with sign, minus 3y equal to 12. So if minus 3y is equal to 12, y will be equal to what? Minus value, right? So y will be equal to what? 12 by minus 3, that means minus 4. Yeah, I hope you will be able to solve this. Yeah. Okay. If not, then please write on the comment box, and I will next time I will write all the steps. Although I don't appreciate that because we are in lecture number 8. We have solved many equations. Okay. Second condition, if you put y equal to 0, so this term will become 0. So you got only 2x equal to 12. So if y is equal to 0, 2x is equal to 12. So x will be equal to what? 6. Great. Correct? Correct. Okay. Shall we draw this? So the first point here, the first point coordinate is what? 0 comma minus 4, and the second coordinate is what? 6 comma 0, x comma y. First coordinate 0 comma minus 4. Where is that? 0, and on y's value is minus 4. So here for the second point 6 comma 0, 6 comma 0. So 0 on y, 6 on x. Okay, so let's draw this here. Yes. Okay. And these two lines, this is line 2. You can see these two lines, they intersect at one point. So pair of linear equation here, they are consistent. Are you learning this? Yes, let's try one more. Okay, let's try one more. Let's try this one. Let's try this one. Again, we'll take the first equation, which is x minus y equal to 8. Again, I will draw the box here. So, yes, x, y. Consider x is equal to 0. If x is equal to 0, y will be equal to what? 8 or minus 8? Take with sign. When x is equal to 0, you have minus y equal to 8. So y will be equal to what? Minus 8. I hope this is clear. Yeah. Now, if I take y equal to 0, then if y equal to 0, then x will be equal to what? X will be equal to what? 8, the positive 8. Let's plot these 2 points on the graph. The first point here, x comma y, which is 0 comma minus 8. Guys, this is a concept builder video. Yeah, so keep in mind, in concept builder video, no shortcuts. We have to go with the right method, the basic method, the detailed method. And when we are solving the next level of questions, I will show you a lot of shortcuts there, so don't worry. 0 comma minus 8, 8 comma 0. 0 comma minus 8. So 0 comma minus 8. On y we have minus 8. And 8 comma 0. So on x we got 8. Yes, now let's join these 2 points and draw a line. That's first, that is by equation number 1. Now second equation is 3x minus 3y equal to 16. Now, okay, let's change the color. Okay, equation number 1. Let's change the color. Okay, 3x minus 3y equal to 16. Okay, this time if I substitute x equal to 0, what will I get? Y equal to, if x is equal to 0 here, look at the term with sign, you got minus 3y equal to 16. So y will be equal to minus 16 by 3. Correct? Then next is, when you substitute y equal to 0, then what is going to happen? Y equal to 0. Let's substitute y equal to 0. What is going to happen here? Then 3x, because y equal to 0, so 3 into 0 is 0. You got 3x is equal to 16, so it will be 16 by 3. We'll take approximate value. Okay, we'll simplify this fraction and take the approximate value. So the first point is 0 comma 16 by 3 is what? 3 5s are 15, and then you got 1 left, so 0.3. So 3 5s are, and then 0.3 with negative sign, so minus 5.3. Similarly here you will get 5.3 comma 0. Let's draw this. So 0 comma minus 5.3. Let's draw this. 0 comma minus 5.3. Somewhere less than half. Yeah, let's take this minus 5.3, and then here you have plus 5.3, right? Correct. Let's join these 2 points. What do you see here? Do you see the lines are intersecting? No, they are not. See, that's equation number 2. They are not intersecting, right? This condition is parallel. This condition is of parallel. Okay, so if the lines are parallel, we will say the linear equations are, the pair of linear equations are, the pair of linear equation is, the pair is inconsistent. So this is the case of inconsistent. Yeah, this is the case of inconsistent. Okay, yeah, parallel, inconsistent. I hope that's fine with you. Yeah, so if the line does not intersect, the lines do not intersect, that is the case of being inconsistent. And when they intersect, that's the case of consistent. Okay, fine. I hope that's clear. The plotting the line on graph, that's kind of a revision. We have done this in the previous lecture also. But are you understanding this? Now, when we have solved many questions like this to understand whether the lines are parallel or consistent or inconsistent, we realized one thing, that if the slope of line is same, what is the slope of line? Slope of line is the angle with positive side of x. The angle with positive side of x. If that is equal, then of course the inclination is same, right? If inclination is same, they will progress like this, like a railway track, correct? Never intersect. Yeah, two lines never intersect. Slope, if the slope are same. Now how this slope and everything work, it depends on the coefficient of variable. Now look at this. Here, if you look at the coefficient of variable, the coefficient of x here is 1 and y is 3 and constant is 6. If you compare these lines with the line which we have assumed here, look at this. Let me create some space here. Paste this here. So A1, here A1 is what? 1. B1 is what? 3 and C1 is what? 6, yeah, respective value if you compare, right? Similarly, if you compare the second line like A2x plus B2y equal to C2, just for comparison, okay? So here you can see the A2 is 2, coefficient of x, B2 which is coefficient of y. The coefficient of y is what? What is the coefficient of y? 3 or minus 3? Yes, take this with sign, minus 3. Yes, so this is minus 3. Coefficient of x is, the B2 is minus 3 and the constant term is 12. Now when you take the ratio of that, look at this. When you take the ratio of that, what do you get? Ratio of what? A1 upon A2 equal to B1, and B1 upon B2. If you take the ratio, what do you get here? A1 is 1. Yes, A1 is 1. A2 is 2. And B1 upon B2. So B1 is plus 3. And B2 here we got minus 3. So if you take the ratio here, the ratios are not equal. 1 upon 2 is not equal to 3 upon minus 3. That's how you understand, okay, the slope are not equal. If they are equal, that means the slope of equations are equal. If the ratio, the A1 upon A2 equal to B1 upon B2, that means we say the slope of lines, both lines are equal, and if the slope of lines are equal, they will progress like parallel lines. Okay, that's the case. So here, if it is not equal, yeah. So when, now this you need to write, when a1 upon a2 is not equal to b1 upon b2, the lines are consistent, the lines will intersect. Noted. a1 upon a2 is not equal to b1 upon b2, then line are consistent or line will intersect. Yeah. Okay, let me write it here. This is the case of consistent when the line intersect. And when do we say that line intersect? When a1 upon a2 is not equal to b1 upon b2, then this is the case. Yeah. So if you have drawn this diagram, you can also write it here, write this. Fine. And when, in which case do you see the line are inconsistent or lines are parallel? In which case do you see that? If the coefficient of, the ratio of coefficient of x is equal to the ratio of coefficient of y. I hope you are not scared of a1 and a2. They are just, we need to consider some coefficients, right? So we are considering a1 and a2. The 1, 1, 1 because of the first line and the 2, 2, 2 because of the second line. Keep it simple. A coefficient of x, b coefficient of y, and c is the constant. That's how we kept assuming since years. Like even if you look at your textbook, the 10th standard textbook, you will find the same a1, a2. So that's why we are using. So there is no compulsion as such. But I hope you understand the a1 is the coefficient of x for the first equation and the b1 is the coefficient of y for the first equation, and similarly for the second equations. Correct? So if a1 upon a2 is equal to b1 upon b2, in that case we say the slope of lines are same. The slope of lines are same. They make same angle with the positive side of x-axis, and that's why they never intersect. Okay, we have seen that with a lot of practice here. You can see in the second equation, even if you only want to look at the equation without plotting the lines on the graph and you want to understand whether these lines are inconsistent or not, you can also look at the coefficient of x in the first equation and coefficient of x in the second equation. That is 1, yeah, a1 upon a2, and if you see b1 upon b2, what do you get here? a1 you will get 1. What is a1? Coefficient of x in the first equation. Please take the reference here. This first equation, second equation. First equation, second equation. You can call any equation to be first and the other equation will become second. So the sequence doesn't matter. Yeah. Don't worry about the sequence also. Come back. Yes, the coefficient of x here is 1 and the coefficient of x in the second equation is 3. If you look at the coefficient of the y, in first equation, that is minus, take with sign, -1, and the coefficient of y in the second equation is what? -3. Yes, if you take the ratio a1 upon a2 and b1 upon b2, both of them are 1 upon 3 and 1 upon 3. So what do you learn here? The coefficients are, the ratio of coefficients of x and y for these linear equations are equal. In that case, slope must be equal. Because slopes are equal, they will be parallel. Because slopes are equal, they will not intersect. Because slopes are equal, this pair of linear equation is inconsistent. They are growing like with the same distance. Yeah, same distance between them. Yeah, clear? Yes. If not, then please rewind this entire video. I hope I could make this concept easy. So, we will see this concept more in detail, this A1 upon A2, B1 upon B2 in the next lecture. So, this is it in today's lecture. My name is Shamanawat and I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.